Mathspace. It's talking about tree diagrams. So Neil plays 3 tennis matches. In each match, he has 60% chance of winning and 40% chance of losing. Now, you might remember this a little bit from last year. So tree diagrams, we've got 2 outcomes, and they're consistent probabilities. They're not changing in any way throughout each time we go through the rounds or the events that are happening. Okay, so we've got 2 outcomes here, and it's happening for 3 matches. So then we go 2 to the power of 3, so we expect 8 outcomes, which is what we get here. Alright, so we've done this tree diagram correctly. And the first question's asking about find the probability that he will win all his matches. Pretty straightforward. So what we do is we look at the branch where it's win, 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 and we have our probabilities of 3 over 5, 3 over 5, 3 over 5. Okay, so then we can either put in our case 0.6 to the power of 3, or we can put in 0.6 times 0.6 times 0.6 if we want decimal answer. If we want an exact answer, then we're going to go 3 times 3 times 3, which is 27, 5 times 5 times 5, which is 125. So our fraction calculation is basically 27 over 125. The second question says find the probability that he will lose all his matches. So again, we look at our tree diagram, go down here where all the losses are, and then it's 2 over 5, 2 over 5, 2 over 5. 2 times 2 times 2 is 8. 5 times 5 times 5 is 125, so it's 8 over 125. If we look at C, find the probability that he will win more matches than he loses. Alright, so if he will win more matches than he loses, so then we look at all the branches that he wins 2 out of the 3 games, or all 3. So we've got all 3, and we already know the first one is 27 over 125. We know that there's win, win, and then a loss here, so that means he wins 2 out of these 3 matches. So anywhere that has 2 wins and a loss, they're the branches that we want to add together. So what we want to do is we want to come up with a overall probability with that. So that's 3 over 5 times 3 over 5 times 2 over 5. So that's going to be 3 times 3 times 2, which is 18. 5 times 5 times 5 over 125. So we know the first one's going to be 27 like we did before. The second one's going to be 18 over 125. We want the third one where it says win, loss, and then win. So that's going to be 18 over 125. We don't want the win, loss, loss, but we want this first one in the losses. We want the loss, win, win. Now, all those losses, win, win, or win, loss, win, or win, win, loss, they're all going to be the same probability because the probabilities aren't changing each branch. Alright, so they're all going to be 18 over 125. So what we can do is we can add them all up. So 18 plus 18 is 36, plus 18 is 54, plus 27 is 81. So we know that it's going to be 81 over 125. Alright, and that's what we get, 18 over 125. So what we can do is we can move on to this sort of thing where we've got Dave owns 4 green tiles, 3 blue tiles. He selects one of the tiles at random for himself and then another tile at random for his friend. So in this case, what we want to do is we want to fill in the probabilities matching the edges of the probability tree. Now this is not that hard because we know how many probability or how many tiles each one has out of the total. So probability is always the number of successes divided by total, as you might see in the summary. So it's 4 over 7. So A is going to be 4 over 7. So we can just type that in straight away, 4 over 7. And that's all it's expecting us to fill in all these boxes. So I'm just showing you how you can quickly or answer these questions. Alright, and complete the Mathspace tasks. Alright, and then we do the next 4 as well. So again, once he selects one of the tiles at random for himself and then another tile at random for his friend. So in other words, he's taking a tile out of the green ones, so then he's going to now reduce the amount of tiles. So this is what we call without replacement. Alright, so he's not replacing the tile back in and pulling it out again. Right, he's taken the tile for himself. So now the next green one is going to be 3 out of 6. So what we can do is in here, we can do 3 over 6, because that's what's happening. Alright, in the meantime, the blue tiles haven't changed, but what happens is the total has changed. Now, we might be able to use 3 over 6, but I think it might be that they want us to simplify the fractions. So we can do the same thing with the next one. So he's gone blue first, then green. So the green tiles haven't changed, that's still 4, but this is now going to be 6. So if we simplify that, that's going to be 2 over 3. Same with the next one, we've got 3, but he's taken one tile, so the blue tile is going to be different, but the total is going to be different as well. So that's going to be 1 over 3. Alright, and you can see here, even if we go through the branches, each branch has to equal 1. Right? So in other words, each event that occurs, so I've got 2 branches here, both of those probabilities have to equal 1. Same with the next branches, those 2 branches have to equal 1. Same with these bottom 2 branches, they have to equal 1. So we sort of get an idea of what's happening here by putting all those in. And there's my answer. So then it says, what is the probability that Dave selects a blue tile for himself? So blue tile for himself, so that's just this one, but then that's someone else. So you got to think that this first choice is Dave's choice, then the second choice is who he's choosing a tile for. Okay, so you got to make sure that you understand the question. All right, what is the probability that Dave selects a blue tile for himself? Well, right here, so it's going to be 3 in 7. So he's going to get a 3 in 7 chance to do that. Calculate the probability that Dave selects 2 green tiles. So again, we do the same thing that we did before, but this time we're going this branch and then this branch and multiply the answers together. So I've got A and C, so it's going to be 4 over 14. Simplifying that means it's going to be 2 over 7. Alright, and we're done. Okay, so some tree diagrams are quite easy, like this, but you still need to understand the fundamentals or basics.